So this is problem 3.4. The stats teacher's cars, a random sample of AP student teachers was asked to report the age in years and mileage of their primary vehicles. A scatter plot of the data, a least regression printout, and a residual plot are provided below. A. Give the equation of least squares regression line for the data. Identify any variables you use.
Okay, so to answer A, we were given this table up above near the where the plots were provided, and everything we don't need. We don't need anything. The only things we need is right next to the constant and car age. The top number we are given, 7,288.54, is our y-intercept. Well, the number right below it, 11,630.6, would be our slope. Putting these together, we can find that the line squares regression line is y hat equals 7,288.54 plus 11,630.6x. That would be line squares regression line.
Okay, B. One teacher reported that her 6-year-old car had 65,000 miles on it. Find its residual.
Okay, so to calculate this, we would need to find its predicted value first, because we already know the actual value is 65,000 miles. So to find this, we would plug 6 years to be x in our line squares regression line we found in A. So typing that into the calculator, we 7288.54 plus 11,630.6. Putting 6 in for x, we would find that is 72.14 miles. We would take this number and we would subtract 65,000 from it. Wait, no, scratch that. We would subtract 65,000.
Why is that?
Because to find the residual, you have to take the actual value and subtract the predicted value from it. So it would be 65,000 minus 77,072.14. And we need to find the residual is negative 12,072.14 miles, indicating that the predicted value was 12,072.14 miles above the actual.
Okay, so that was B. Right, okay. And then C, interpret the slope of the line in context.
Okay, so we already know that this is our slope, so that's 11,630.6, that is our slope, and that indicates that for every year the car ages, its mileage will go up 11,630.6 miles.
Okay, so that was C. Now D, what's the correlation between car age and mileage? Interpret this value in context.
Okay, so one of the other pieces of information was r squared. This would be the coefficient of residuals, correct? Okay, so we got 82% for that, but of course since it's, so to find r from r squared, we would need to find the square root of 0.82 because percentages in themselves are decimal places too. We just need to carry over the decimal place 2 over. So you would input 0.82, find the square root of that, and that would be 0.9055. But as was seen in our graph, it had a positive association, meaning that the residual, the correlation would be positive. So that is why it is a positive as opposed to negative. And this indicates, because it is just 0.1, about 0.1 away from being 1, it is a very strong correlation between x and y, so car age and the mileage.
E. How well does the regression line fit the data? Justify your answer using the residual plot in S.
Okay, so we were provided with this residual plot, and as can be seen, there is no pattern. Like, this would be our zero line, but there is no pattern above and below. It's just scattered So this in itself indicates that it would be linear. The S being
Standard deviation of residuals.
standard deviation of the residuals is, let's see, is 19,280, and that would indicate that the average error for the predicted value is 19,280, and this, it's close, but it's really not that accurate when you would be buying a car, but overall it would be accurate for most other situations, and good to use, but you would probably rather just find the actual. And that is the end of this problem.
By Liliana and Miali, this is 3.2.